All right, so now we're going to move on to our last functional group that we talk about in organic chemistry, and that is the amide. Notice that the previously what we were talking about, let's just make this really clear because I know that these words are pretty similar. Previously, we had been talking about amines with an N, A-M-I-N-E. Now we're talking about amides, A-M-I-D-E. Okay. As sort of with a lot of these functional groups, we can see amides in medicine, in particular acetaminophen, sorry, blanked on that, is the active ingredient found in Tylenol, and that has an amide group in it. What is an amide group, right? So it's similar to a carboxylic acid. Remember where we had this carbonyl component and then the hydroxyl group bound to that carbonyl carbon. An amide is a carbonyl group that has a nitrogen bound to that carbonyl carbon. So this is an amide. Okay, and amides can be prepared from amines and carboxylic acids. Okay, so this would be called a condensation or amidation reaction where you have a carboxylic acid reacting with an amine to form an amide. So let's just sort of see what's up here. Right, so we have a carboxylic acid, in this case propanoic acid, that's reacting with ammonia and this creating an amide. Notice that this portion here is coming from my carboxylic acid, and then the ammonia is losing one of its hydrogens and replacing that with that carbonyl carbon bond. All right, so let's see if we can't figure out how these would join together. Now we have, again, that same carboxylic acid, propanoic acid, but now it's being combined with a primary amine. And again, we're going to get that carboxylic acid chunk. Notice that that contains that carbonyl carbon. So this is going to be one way that you can figure out which chunk corresponds to what. The carboxylic acid contains that carbonyl carbon. And now we have that nitrogen on there. So again, this amine lost its hydrogen and then replaced that with a bond with the carbonyl carbon. All right, and water is a second product there. All right, so this is not unlike what we saw with esters, how we took carboxylic acid and alcohol to make an ester. Here it's a carboxylic acid and an amine will make an amide. All right, so what's the product of this reaction going to be? Okay, so again, here's my carboxylic acid chunk, and this is going to contain the carbonyl carbon of the amide. So if I'm going to kind of write it tilted a little bit so I have room. All right, and then I have to add this chunk on here. Get a different color. And that nitrogen is going to lose one hydrogen, so it will keep one of them. And then the other gets replaced by that carbonyl carbon bond. So this corresponds to what was formerly my amine, and this corresponds to what was formerly the carboxylic acid. So being able to predict these products is going to be an important part of this reaction, or this chapter rather. All right, so how do we go about naming these? Actually, really similar to how we named amines. We used the suffix amine at the end. To name amides, we use the suffix amide at the end. Okay, so this is 4 carbons, so that's bute, right? We got our bute from the 1, 2, 3, 4 carbons, and it's an amide, so this is butanamide. Much like our carboxylic acids, they're always going to be located at the ends or on carbon 1. So we don't actually have to include the number for our amide groups. They're always going to be on carbon 1. Okay, so there's no such thing as 2-butanamide. It just wouldn't, you can try to draw it and convince yourself that it's impossible to do. So yeah, so for amides, we don't have to indicate the position of that amide group. It's always on carbon 1. Okay, so if we have a really simple one, that would be, our 1-carbon amide would be methanamide. 2-carbon amide would be ethanamide. And then, of course, we have our special benzene one we have to remember, which is, in this case, if you have a benzene or an aromatic amine, it's benzanamide. So actually not as different as some of the other ones. Kind of easy to figure out. What's going to make naming amides a little bit more of a pain in the butt is if the nitrogen is bound to multiple other carbons. Okay, so, and let me just hammer this home real quick. If these were, instead of being methyl groups, if these were hydrogens, then this would simply be butanamide. But since I'm going to replace those with methyl groups, now I have to indicate the position of those methyl groups. Normally we do that by whatever carbon they're bound to, but whichever number carbon they're bound to. But in this case, because it's a nitrogen, we're going to use these letters N to denote, and let me actually switch my colors to be consistent. So this chunk here, specifically these two groups here, would be NN dimethyl, and then we have our butanamide. Okay, and again, just as always, I'm not going to bother with the common names for these. All right, cool. So coming in blind, IUPAC name, what are we going to do? It's easier to find the parent chain than it was with just regular old amines, because you're going to look and see whichever chunk contains that carbonyl carbon. Right, so this right here is automatically my parent chain because it contains that carbonyl carbon. So this is but and amide. And then in this case, I also have this methyl group that's attached to that nitrogen that I have to indicate. So this would be N-methyl butanamide, all one word. So let me close the, oh, I can't. That's all one word. All right, we're going to go for these ones as well. This one's pretty simple because I only have 2 carbons. So this would be F and amide. Now for this one, I have to figure out, for the second one, I have to figure out what my parent chain is. But remember, for amides, it's a little bit more straightforward than it was for amines, in that I'm going to include the carbonyl carbon in my parent chain. So here, my parent chain, I can tell right off the bat, is a propanamide. And now I have this other chunk that I need to make sure to name, which is this ethyl group that's bound to the nitrogen. So this is an N-ethyl substituent. So this would be N-ethyl propanamide.